Hey, and welcome back to this series where we are making Tic Tac Toe games with a twist. My name is Justin and I'm a full-time game developer, and in the previous episodes we created a basic but flexible Tic Tac Toe game and then focused on the AI. After we created the basic and the AI, we started focusing on adding some twists. Our first twist was creating Tic Tac Toe Ultimate, or maybe some of you know as Super Tic Tac Toe, Meta Tic Tac Toe, Tic Tac Toe Toe, or any other fun name you might know of this variant. This Tic Tac Toe Ultimate already added a lot of possibilities for new features, and that's why in the last episode we started to focus on tackling one of the most common and annoying problems in our basic Tic Tac Toe, which is resulting in a draw or a tie. I believe this is already a good foundation to move towards Unity 3D engine and focus on some more advanced mechanics for Tic Tac Toe. But before we're gonna do that, I want to encourage you one more time to play around with the basic foundation we already have. So let's go and do that first. There's a lot we can do with our basic Tic Tac Toe, but let's focus first on adding some effects. For example, now we already have a win effect, but we don't have an effect once we place the markers. When we place the markers, it's all gonna be static, and when it's win, it has this fade animation. And I was thinking about an animation where it will scale from big to smaller once it's placed, so it has a sort of impact feeling. So let's add that to our marker quickly. What we can do here is we can add a scale to our marker, and I will set it to 2, so it will always start with a scale of 2. And for our render, we can set this scale. And let me first say, for example, int marker size equals to size times our scale. And then we're going to replace the size here by our marker size. If we're going to test this, we will see our markers twice as big. And also it feels placed a bit wrong because it's not centered. But let's make the size work by scaling it in once we place the marker. So instead of owning the scale, we will also need a boolean to notify when we are wanting to scale. So here I will say boolean animate in. And every time we create a new marker, we will say this dot animate in equals true. And then for the update, we will say if animate in, we're gonna run this animation. Scale in. And with the delta time. And let's generate this method. And in here, of course, we also need like we have here as well, a speed. Let's just add it here as well. Private float scale speed equals to let's say 0.1f. Actually, let's make this size also a float, so it won't have some wrong calculations. And then we should cast this to an integer. Our draw image requires an integer to draw. And in the scale in, I will say scale minus equals our scale speed times delta time. And then we will say if our scale is below 1, because we want to scale it from 2 to 1 in this case, we will set the scale to 1 and animate in will be false. We made actually a mistake by making the size a float. This should stay an integer. This doesn't really need to be a float. And we need to make our scale a float in this case. Let's put them under each other. And now if you will run it, you will see them animating. And this has to do because we always draw from the top left anchoring. And we still want to be able to do this, but once it's scaled up, we want to move it just a little bit up. So to do this in our render, we can do this by making a new variable I will call pivot. In this pivot we will calculate the size minus our marker size. And what this will do, it will give us the difference between the scaled size and our desired size. And we take the middle from that. So if it will take the middle, it will be centered towards the scale position. And then we just have to add that to our x and y. So in this case, I will call pivot plus pivot and y plus pivot as well. And if we will then run, we will see it being centered, as you can see. which is giving a much more dramatic effect actually than what we had always before. But I'm still not really satisfied. I also wanted to fade in actually instead of only scaling, because now it still feels a bit abrupt if we place a marker. Therefore I will set the alpha here to 0. And then in the scale in method we can also put our alpha and then plus equal our scale speed times the delta time. So they will be linked together. And then we will also say if alpha is bigger than 1, that means alpha equals to 1. And actually we will change this as well. I will call this we'll make a new boolean for this. Is scaling, and boolean is fading. And then for the is scaling I will say equals to that condition. And for the is fading we will use this condition. And I will actually turn them around just for readability, because otherwise, well, we want to check if it's not needed to scale anymore. We will set the scale to static, and if it's not needing to fade anymore, we will set the alpha to static. And if is scaling, or is scaling. I'm sorry. And is fading, or actually is not equal to. So if both are if both are starting to get reset, we're gonna set the animate in to false. And we will only do this, it's not really needed in this case, but in case we want to have a shorter fade speed, for example, we can still set here fade speed. Then it will still animate in all the way until the alpha is full, and even though the scale is already set. So this will always be set when both are done. But for now I want this to be scale speed as well, because I like them to be synchronized. Let's check this. So now there is a fade, and I can show you quickly as well. Let's put this to 001 F actually. I think there will be a really slow fade. It's even so slow you can't even see the scaling, but it's still fading even though the scaling has been done. Well, let's make it 001 to prove a little bit better. So here you can see it fading really slow, but I'm not really a big fan of slower alpha fade than speed, so I will keep it to scale speed. Now we have a bit more dramatic effect to our games, which makes it much more interesting to play. One thing we can also do is adding a little screen shake once the marker are placed on position. I think that can add a lot of fun effects to the game as well. So that's even more dramatic as we have now with the fade in animation. So we also have some way of dramatic feeling every time you do something. So let's do that as well. And before we're gonna do that, I will create a new class or a new interface. And this will be our observer. Or I'll call it marker observer. And this will just say void animated. We will use an observer pattern to call out once the marker is placed. I will not go too much in depth about the observer pattern, but I did once wrote a full blog post about it. So I will link that below if you're interested as well. But for now we will just add a really basic implementation of this observer pattern. I just want to use it once the marker is animated. So in the marker we just need one. Normally for the observer I will create a subject where we will store all the observers. But for now it's not really needed, so I will just add one observer to this marker. And called iMarker observer is our observer. And here before update I will create a new void as well. we'll call public void register observer with our I marker observer. And this dot observer equals to our registered observer. And now in here, not only if animated in, I will also create a new void fire on animated. And this will check if observer is not equal to null. We will say observer animated, and then in here you can just fire this on animated. Then now we can focus on creating a Screenshake. So we'll create actually a new class I will call Screenshake, or Screenshaker, maybe a better name. And this I will implement the iGameObject interface. So we have the update and render. And what we're gonna do here, we're gonna eventually shake our panel. So first I want to have a constructor for our screen shaker. And then I want to have a JPanel, since our game panel is part from JPanel. And call it panel. And I also want to store this, so private JPanel, and then this dot panel equals panel. What we then will do is add the observer here. So I'll say here I marker observer, and then add the unimplemented method here. And I will create a new private variable, which is our boolean shaking. Is shaking, and this will be defaultly set to false. And if it's animated in, or if it's animated in this case, we will say is shaking equals to true. And then in our update we will say if is not is shaking, we will just return. And this will just stop our update from calling. So now we can do all the shake logic here. So for the shake logic, I want to have a private int x and a private int y. This will be the x and y positions where we're gonna shake to. And then I also want the intensity. And I will just set it to 50. So this means we're gonna eventually set it to randomly move -25 and 25 on x and y. And we also need to maybe want to have an interval between each shake instead of every frame. So to create that, we will need a few variables as well. So I first will create an interval, which is let's say 0.1. Every 0.01 second we're gonna do a shake. We're gonna have a max shake, so how many times do we want it to be shaking? Max shakes. And I want it to be 5 shakes every time. And therefore we also want to have how many shakes we currently have, which is always 0. Or at least when we start it will be 0. At some point it will be another value. And we want to have our current time, which is starting from 0 as well. Therefore we will now also need a reset. So we'll private void reset. And the reset will basically just set these settings. We'll just copy paste them here. Set the current shakes and current time to 0. And actually also set our x equals 0 and y equals 0. So it will not be stuck at one of our shake position. And then let's focus on the logic here. So we first say current time plus equals our delta time minus 1, since it's always 1 dot something. And then we will check if the current time is bigger than our interval. We will say current time minus equal interval, and current shakes plus plus. And then if our current shakes is bigger than our max shakes, it means we have to stop. So we will say is shaking equals to false again. So it will return here and wait for the next time the animated will be called from the observer. And we will call reset. And else, if it's the current shakes is not exceeding the limit yet, we will say x equals to int and then math.max or random times our intensity, but minus our intensity divided by 2. And what this will do, this is going to be from 0 to 49. But we also want to have, we want to move it along the whole size or along the whole screen. So also go minus. And therefore we're gonna clamp it this way, so it will start from minus 25. If it's set on 0, it will be minus 25. If it's set on 10, it will be 15, and so forth. And we can actually do exactly the same for our Y. And now we have to make sure, or we have to make it work, that our observer will be linked to our marker. So therefore in the grid, I will here add a observer as well. I marker observer. Well, I create it here as well with the selected placement. Private. I marker observer. And then this dot marker observer equals to marker observer. And then when we create or place the marker here, we will say markers x and y dot register observer is the marker observer. And now only in the game panel we have to create our screen shaker. Private screen shaker. And here I will say screen shaker because will need it for the grid equals to a new screen shaker. And we have to pass this because we want to shake the whole panel. And for the grid we will add the screen shaker. We will add the screen shaker to listen to each marker when it's placed. And this way it's much cleaner. We can pass anything. For now it's a screen shaker. The grid doesn't know. We know here that it's a screen shaker, but inside the grid and inside the marker it has no idea it is the screen shaker class. It just knows it has the iMarker observer, and it will just call that function which is in it. And for here we will also update the screen shaker. And we don't really need to render it, since we will just update and shake the screen shaker based on when a marker is placed from inside the grid. So let's test this real quick. And we have no screen shake yet, so let's first find out what's wrong. I will first want to have in the screen shaker, I want to have a check if it's animated. So let's say shake. And it does work. So there's something wrong with our shake. And I actually see it. We are not really applying our X and Y. So let's say here our panel dot set location with the X and Y, which is the X and Y. And I set it here because we set here the X and Y, and here it might be reset, and then it will set it back to 0. So if it's at the last shake, or if the last shake has been done, it will still, before it's gonna reset and never been calling this again until the next animated is calling, or is called, it will set the location still back to 0. So let's try it out quick. And it's still not working. Let's just quickly run through our variables. And I see now here we have our current time is set to an integer, so it will never be added up these little values, so the current time can never pass the interval since it will always stay 0. So let's try once again. Now it does do a really weird shake. And therefore we can try and set these axes ones in a little, or block them in a little. Now it seems to work, at least for the X, so let's do the same for the Y. Sometimes we just need to play around a little bit and trial and error our way through. And now we have our really cool, quick and destructive animations. Let's also quickly add it when we animated our move positions. So here I will say if X equals to target X and our Y equals to target Y. Actually the same as we've done in the here in the scaling. And let's try this out once. Maybe this is a bit too extreme. Let's see. Oh. Let's also just make the move speed a little bit quicker. And I think we can make the screen shaker also a bit less. Let's say an intensity of 30. So this is now really making some impact to it. These are just two very simple examples what we can do with playing around with effects. I'm really curious what you will come up to if you're going to play around with this project, so let me know if you created something cool. For now I will just continue on and fast forward the rest for this video, and I will create a menu so we can play everything together which we created in the past episodes. I will just hack it in all together and see how it will look, so I will see you back at the end of this video. So this was it for this tutorial. I really hope you enjoyed this series. This is now the end of the Java series. From now on we will move forward to Unity 3D Engine and work on some more advanced mechanics for Tic Tac Toe. And therefore I will also try to experiment with different type of video editing, since this is all new for me. So therefore it might take a little bit longer for the next video to come online. But once it will come online, you will see them coming more consistently again. So for now, if you have any questions or have any feedback as well, I would really like to hear them down in the comments or send me a direct message. I just started this channel and I would really value if you give me some feedback on what you think can be better or think you don't really understand yet, so I can try to clarify them or try to improve myself on them. So for now I really hope to see you in the next video. I can't wait to share what's coming next, and really let me know if you already created something cool with Tic Tac Toe already, or if you're gonna create something now cool since this tutorial series. I would also really like to see them. But for now I really hope to see you in the next episode. Goodbye!